So the sense of smell has long played a fundamental role in human development and biosocial interactions. Consequently, the olfactory sense has become a key element in development of many commercial industries that manipulate the aroma properties of their manufactured goods in order to improve product appeal, quality, and consistency so that consumers quickly identify with individual brands having unique scents. Fields such as agricultural, biomedical, cosmetics, environmental, food, manufacturing, military, pharmaceutical, regulatory, and various scientific research fields use the sense of smell. So, unfortunately, we only have a limited number of noses for each person, and that is where the man made or electronic noses comes in.
I'm Mark, and I'm here for some wine tasting with my friends. However, my cold has affected my sense of smell. I really can't smell anything. But good thing I have here my electric nose to uh, to help me identify what I'm drinking. But how does that even make any sense? Here, let me show you. Comparing it with the real biological nose, the components of the system carry the same functions as the human body. First is the sensors array in line with the olfactory receptors. However, sensors array really don't take the smell but obtain the molecules that contain the odor, in effect extracting those molecules much as the receptors would. These then move on to the pre-processing of the signal, which is done by the olfactory bulb in the human body. Upon reception of the aroma, these will send signals to the brain or the database. From there, a decision will be made to identify what the nasal cavity and the electronic nose has received. Much like how the brain sees distinct features of everything to give identity to things, the electronic nose will be using pattern recognition to find distinct features of what the sensors have detected. Now, I hope that made sense and I explained how the electronic nose works. Oh, we're drinking beer now. Aye. Well, to me, every kind of beer smells exactly the same, but to better explain the electronic nose, here is the block diagram that will use beer as the sample. So aroma in the form of odorous molecules will be extracted by a certain component in the device. It will be received by the senses array that will send electronic signals upon detecting an odorous molecule. The control and measurement system pre-processes the signals it receives from the sensors array and reorganizes it to a digital data that the pattern recognition model can comprehend to form its conclusion based on the features of the aroma. From there, we can identify the sample we have. Right? That's all for the workings of the electronic nose, and remember to drink responsibly. Drink water, not alcohol.
So, as there are many fields that use the electronic nose, different types are also used for different types of aromas to be smelled. So, the different types of electronic noses are organic polymers, metal oxides, quartz crystal microbalance, and even gas chromatography, or combined with mass spectroscopy, can be used in a non-selective manner using chemical mass or patterns as a e-nose or electronic nose. Metal oxide sensors consist of three layers, and when dipolar compounds interact with the metal, the electric field is modulated and recorded by the transistor. The quartz crystal microbalance, or the thickness shear mode resonator, is the best known, oldest, and simplest type of piezoelectric acoustic wave device. While gas chromatography is an analytical technique used to separate and detect the chemical components of a sample mixture to determine their presence or absence and/or quantities. So, polymer gas sensors operate based on changes in electrical resistance caused by adsorption of gases onto the sensor surface. And the last one is mass spectroscopy, useful for measuring the mass to charge ratio of one or more molecules present in a sample.
So now that we know how it is applied and how it works and what are the different types, now let us talk about the advantages and limitations for each type of electronic nose. So the first one is the catalytic bead, or calorimetric. So the advantage of that is that it has a fast response and recovery, and it has a high specificity for oxidation or oxidized compounds. The limitations or the disadvantages is that it is sensitive to oxygen containing compounds. So the second electronic nose is the conductive polymer sensors. The advantage of that is that it has an ambient temperature operation, sensitivity to many volatile organic compounds, short response time, and diverse sensor coating, and it is inexpensive and resistance to sensor poisoning. The limitations is that it is sensitive to humidity and temperature, overloaded by specific analytics, and third one is the life expectancy of this sensor is very limited. The third one is the metal oxide semiconductors. The advantages, it has a high sensitivity, limited sensing range, fast response time, recovery time for low molecular weight compounds, and the limitations is that it consumes a lot of power, weak acid poisoning, limited sensor coatings, sensitive to humidity, and it has a poor precision to most of the gases. And the last sensor is the quartz crystal microbalance. So the advantage of this sensor, it has a good precision, high sensitivity, diverse range of sensor coatings, and the limitations are complex circuitry, poor signal to noise ratio, and sensitive to humidity and temperature. So that is the different advantages of each sensors.
Electronic nose or machine olfaction is still in its early stages. More development is still needed to make it a mainstream sensory device. Due to its early stages, only few e-noses are in circulation as of the making of this project. One would be from NASA, the National Aeronautic Space Administration. An article from the pathologist entitled Breathe In, Breathe Out showcases a new development in the electronic nose technology. NASA unveils a new handheld breath analyzer that detects specimens for declining health. The e-nose will analyze the breath of the user to ensure that astronauts in outer space are in good health and are capable of doing tasks required by them by the administration. Like other developments in technologies, in the future, e-nose breath analyzer will be mainstream and easily available to the public. This will be an easier alternative for visiting the doctor for daily, weekly, or monthly health checkups. On other markets, electronic nose is also applicable in laboratories, specifically in quality control of an environment. As we advance our measuring instruments, our laboratories are in need of better control of its environment. This depends on the type of experiment, but in cases where air can be a factor in an experiment, e-noses can be used to control the air inside the laboratory. E-noses can detect different chemicals or dirt in the air, and combined with different filtration systems, can ensure that a laboratory can cater to the needs of the scientists to perform experiments without error from uncontrolled factors. The electronic nose consists of different arrays of chemical sensors that mimic the protein receptors of a human nose. Each sensor is made to respond to different odors. When a sensor reacts to a specific odor, a electronic voltage is produced and is analyzed by a computer to identify the odor. Different applications of the e-nose requires different set of arrays of chemical sensors. This can be specific, like in a lab setting, or a general array that can be used in a public area. This depends on the specialization needed by the operator to utilize the e-nose.